My name is Christy, and hopefully you familiarize a little bit about what we do. I work for MHE Labs, which is McGraw-Hill Education's R&D lab. We're based in New York City, and I didn't get the memo. I'm not supposed to wear dress in a suit. But at the end of the day, I feel like we should bring a little bit of New York and a little New York media kind of vibe to a California-based Database Geek conference. What's interesting is how similar our goals are, even though we are a traditional media publishing company looking for our new role in the digital media world. I always look at that and I felt like I misspelled it, EdSense ED. But the truth is that I think a lot of what we've learned from advertising and from social gaming do apply very well in figuring out how we can adapt to individual users and making them feel like when they're learning that someone is like looking at them and care about what they do. So let's zoom out a little bit and look at MHE Labs. We do have the McGraw-Hill icon in our labs. You guys are probably familiar with that on the spine of the textbook, a little red block, usually signaling quality and sometimes high prices. But the idea here is that we do believe that there's a value in bringing professionally curated content, to bringing the idea that you can bring different people together, different ideas, and deliver it digitally. So, we're doing a lot of research and development, both in technology, but also we are part of the McGraw-Hill Education New Ventures group. So I report to the Senior Vice President of New Ventures. We do M&A stuff, and if you have an education startup you want to have us take a look at, please come to me, and we'll start there. But the important thing about New Ventures, not just about investment as a passive investor to try to see if we can get ahead of this game, is that there's an opportunity, I think, for McGraw-Hill to bring our access to the customer to companies, starting edtech companies or even technology company, to get access to a business, to get access to a user base within university and schools that you couldn't get before. And I think that's, a valuable role that we can play. And the way we're going to do that is that we're going to do it through an openness that is probably unexpected from a company with such heritage. And we do actually believe in open source, right? Because education is about sharing knowledge openly. I believe good content deserves compensation for the person who created it. Some people, if I ask you to use a McGraw-Hill book, you might say, I don't really want to do that. But if I invite you to write one, you say, please talk more. So there's some really powerful thing about being able to share through some sort of mechanism. But software as a way to get that done is actually pretty important, right? So we want to be able to invite people to innovate on what the future education in. And the best way to do that is to have people share the tools. So I'm a big believer in open source. Beyond just using open source as a way to maybe save money from a deployment point of view, and that is one way to think about it. A more powerful way of thinking about it, and the reason I'm here, is that if we all work together on a set of tools that's shared, and we create standards or at least interoperability between learning system and learning content, then we are more able to really tailor, information to students. I'll get to that in a second. So I will put that aside on the right or left, depends on how you look at it, and talk a little bit about the problem domain that we've been trying to solve. So it's clear that learning is moving online, whether it's exclusively online or partially online, hybrid or fully online. We know that a lot of students are doing that. Some of them are doing through massively online course like Coursera, what they're doing. Some of them are doing because they're taking online MBA program, and schools who are struggling with spaces limitations are doing more of their lectures online and treating the in-person session as more of a collaboration or study group or recitation. But it creates a really, really difficult challenge, is that if you were to build an online learning environment, you're dealing with a tremendous problem of scale. People use the online tools a lot. You enroll in a course, you're going to click that a lot. Probably they will still play more games and check more Facebook, but still, this is not a small number of clicks you're talking about if you have a large enough footprint. And the second thing is that we also have to deal with the problem of heterogeneity. Not only are we dealing with McGraw-Hill content, we want to bring other people involved in this, and obviously there's other premium content provider who wants to get access and say, hey, here's an excerpt from The Planet from BBC that could be useful if you're trying to understand something about astronomy. Currently, we can't do that. There's no way for that bits of information to inform and help people understand how they can learn this better. So we want to provide a platform that allows us to figure out maybe the metadata, maybe even the actual content itself about these kind of heterogeneous sources. And open content, obviously. Open contents are created by people, right? They don't come into being from nothing. And people who are more concerned about getting this stuff out there than getting compensation for them, but we want to give them an ability so that people can find them. And the best way to be able to find the content is put in a context of learning a course or the future replacement of a textbook, something that provides reason for that piece of content to be in context of what you're trying to learn. And I think that's incredibly valuable. But the focus I want to talk a little bit about today is two kind of interesting kind of edge case of what the technology doesn't really allow us to do today, and hopefully we can do that in the future. One is this idea of learning apps. So right now, learning apps are typically thought of as iPad apps. You have very touch gesture, but they are what we call sovereign apps. They take up the whole screen. They cannot be incorporated into a curriculum. Even if you look at iTunes U, there is a lot of switching back and forth between a video player and the ebook and whatever apps is being included in that curriculum. And there's a great opportunity for us to see if we can, use the power of, JSON and JavaScript. Can we describe those interactivity, these apps, in terms of things that can then be merged together with more traditional content that doesn't have interactivity, but deliver in context in a learning environment that's coherent? Because once you can do that, then we can start tracking analytics about what people are using and whether they're successfully using that tool to learn in a much more even way. So whether you read a textbook chapter or an ebook chapter and learn the material, or you played a game and then you learn the material based on some assessment that we'll put together. The assessment item itself could be an app of some sort, a multiple choice question, it's just a very simple JavaScript app, a physics simulation where the result is indeterministic, but if you're in the right range, they give you credit for it, would be a better assessment vehicle. All that stuff can generate data, and that data needs to be captured and needs to be analyzed. And that problem space looks like a good fit for the little couch sitting on the corner over there. But broader, our strategy is to leverage two undeniable forces in the marketplace. One is that HTML5 as a presentation standard, as a way for people to interact, is definitely the right way to do it. PDFs and Flash, not the right way to do it. Or even very proprietary, well-constructed Objective-C based application has limitation of it takes up the whole screen. It can't be assembled to a larger context. And Google, Microsoft, Mozilla, and Apple are pushing that envelope on that really much. And we're just essentially taking advantage of that if we can build on top of that. It's naturally desktop and mobile for good reason. And JavaScript is some really powerful thing. I think that is the new way of describing learning units. Not necessarily JavaScript as learning tool, but it can facilitate the type of interactions that we are now not seeing yet in education. And then for the cloud, the good thing about the mobile use case is that it forces us to think about building API so we can serve both a web front end and a mobile front end. And that's an API cloud that gives you access to professional content, that allows you to do content management and allows you to use that API to tap into, let's say, a news archive or picture archive from AP, but in a way that your HTML5 apps is like, hey, do you want to pick a picture from all the pictures that AP has ever put together? Hey, here's a bridge by way of this consumer-facing API that you can get to some of these premium resources. And that unlocks the value that exists somewhere else into the learning experience of the student. And the other thing about API is, whether you talk about security of not seeing the test answer key before the professor leverages, or whether you should not have this premium content, assuming that it must be licensed or some sort of fee needs to be paid, there needs to be a security model. And that really requires us to, provide what we call no God mode. Every application, like using a Facebook API, you first have to declare who you are, and then you can see what you can see. I think that model makes a lot of sense in the educational API space. But the challenge is that if we were to build this cloud, let's call it an interactive content delivery cloud. as compared to a content delivery network, which doesn't have the same interaction activity. It needs to be elastic. It needs to come from many sources, low latency. And it needs to do full text, right? I need to be able to see, find a piece of content out of the haystack, what my professor has put together, what I have read, what I have seen, what I've created. That should all be searchable. And the most important thing about, I think, the opportunity that we have is that online, everybody doesn't have to look at the same thing, right? That's the power of Facebook. Everybody logs into Facebook every morning, see completely different things. It sees the things that matters to you. And I think that type of rating and recommendation is a great opportunity for us to really allow online learning to be superior to in-person learning, where if you ask 3 questions at the end of the class, you've just taken up 15 minutes. Whereas you can actually ask a lot more questions online and have a lot more answers that is relevant to you, to the people who want to help you, whether it's a professor or someone else. So we looked at many different things. We looked at XML database. A lot of them are in use internally at McGraw-Hill to build a content management system. In-memory data grids as a way to speed things up. Memcached, Membase is one of them. There are other ones that's used in the financial service industry that we looked at. MapReduce engine for analytics for marketing trends and clickstream. And those are useful in enterprise search engine with very interesting natural language processing. But the problem we run into is bringing all those things together for interactive cloud. If we were to anticipate the number of users that we'll get for learning, which is almost everybody in this room and everybody's kids in this room and stuff like that, that is not an enterprise sales concern. That's an internet scale concern. So going to the enterprise vendors for that has some value. They help you get understanding. But we need something like planet scale, right? And on the other hand, we also start looking at the problem of interactive content to be kind of a caching problem. I want you to access this course that's already been assembled by your professor, but you don't have to join everything. It's all there. Next time someone looks at that same lesson, it's in memory. It's fast. That's good. Social gaming. Oh, 6 people view this. 4 people find it useful. You have successfully read enough articles to go and take the test. That seems like a social gaming problem. And finally, with all the statistics, be able to recommend content for you to look at, that seems like an ad targeting problem. Okay, that makes sense now. That's why McGraw-Hill looked at Couchbase and especially the future vision of it and say, let's take that as one of the foundational technology we're going to use. But we know it's missing something. The first one being full text. So we know that we need to complement the ability to do this real-time CRUD operation with the ability to look across a data set and kind of fuzzily decide what would be a good match. And search engine, credit Google, have done that. PageRank done in Hadoop or something like it, right, MapReduce. And then that number, 1 to 10, 7, 8, gets into a search engine, and that's runtime, doing a bunch of analysis of a location and do that really fast. So that's a good match, right? You do some analytics in a system, maybe you even have Hadoop in that, but then you serve that out via search engine with an inverted index with the efficiency you would never get with a SQL query. On the other hand, now that we're speaking JSON, it would make sense for us to figure out, could we use JavaScript as a way to generate the actual HTML5 interface from the JSON? So JSON, the data, plus JavaScript, the code, gets you the interactive experience that we know. So we invested heavily. We're working with Yehuda Katz and Tom Dell. Yehuda is obviously famous for his Rails 3 work, and say, why don't we take the Ember.js framework, which competes with Backbone and Angular and other type of JavaScript framework. And we find that there's a really good match about the data model that we will get in Couchbase and the ability for that to become the model on your browser to give you that interactive experience. It makes a lot of sense. And we have to glue it together, so we are starting to write a Java-based, actually JVM-based integration framework to do the least amount of possible to bring together JSON on the server side and JSON and JavaScript models on the client side to create that real-time experience all the way to the client. So this is how it looks in a stack. Obviously, JavaScript HTML on that one JSON document, but both in search index and the persistence, MapReduce for some top analytics, and the very powerful ElasticSearch query DSL that allows you to kind of express what you want, kind of filters and ranking in a JSON document. unrelated to the actual document you're storing. That's really powerful. We'll see some examples of some of that on screen a little bit later. We'll skip all the magic to glue the two layers together, but what we're trying to do is build basically Meteor, which has got some investment about like using MongoDB on the back end and then have a client-side JavaScript framework in the front end. We will do something like that, but with Couchbase in the back and Ember in the front. And that's what that Zinni layer is for another discussion another day. So let's take a look at what our vision is. Our vision is take the textbook, tear little pieces of the textbook into a little thing like a card, 3 by 5 in size, not necessarily, it's a metaphor, right? It's not actually, and it looks like web content, so it's rendered in HTML5. And you can have different types, something that's come from a textbook, something that you drew up using an iPad or a tablet or whatever it might be. It could be a formula that the card itself is just a formula you typed in and it renders through some logic the actual charts. And it could actually have an edit mode. And this is where card looks like a mobile app. Every card has an edit button. So we have compartmentalizes the editing function right to that unit of content. Edit button is built in. And you can certainly edit this chart by moving around or change the color, but you're only influencing this particular piece of unit. And this essentially, video would be another asset we can put together, gives us the atoms of which we can assemble this learning environment. And because these things are JSON documents, you can start moving them around. You can start syndicating templates of a course that contains multiple cards and copy it over to a new specific section, and then the professor can modify that. Document is helping you, unbound by the fact that if this was a relational database, you have not an ability to extract anything because everything is tied together. With the document database, which means that all this card state is persistent in JSON, then on the back end, all you have to think about is how do I store the JSON, how do I search the JSON? There's tricks and things about generating searchable indexes versus more like third normal form-ish thing versus combining nested document, but you can now store it in a transactional cluster, push it into an analytic cluster, take it back out and get an aggregate number and update another field in your transaction cluster, push those information with your page rank or your recommendation rank into ElasticSearch, have people search on them, and then once you get the results back, serve out the actual document, the actual video metadata back to the end user. And that's how the visual thing can be rendered. So it's real time, it uses NoSQL technology, and we are using the Memcache protocol as a way to coordinate that, which means it can be delta, so we can push back incremental changes, not just entire new documents. Some really powerful thing we'll talk about in a second. So we have decided to do a proof of concept around this concept of bringing together Couchbase 2.0 with this document model with Elasticsearch so that the full text article and the metadata is in Couchbase. In addition to that, we'll also log every view that you see. Student accessed an article, a learner clicked on something or created something, we'll track that as an event log. And based on that information, we'll have a flowchart of how exactly that works. We push new documents into Elasticsearch with the most updated information. And then, based on the relativity scoring, when you actually perform the query, leverage all the pre-existing, pre-aggregated information to make that work. So, we went to Couchbase not just for the engine. We actually went to Couchbase and offered them a collaboration between MHE Labs and Couchbase. They know the engine, and we know our use case. And we are saying, let's build a proof of concept, right, of how you would glue together in an application. So this is, I'll go through the UI in a little bit, something that would prove that this is actually going to be working. And let's do it in an open source way. So you can now, at the end of the talk, I'll have a URL, download everything the Couchbase Labs has done, and Dipti has worked on it, Chris has worked on that project as well, and Marty led the development on that, and he'll have a talk about the Elasticsearch integration later in the day. We want to see, could we build something that looks like a ranking system where when you click on an article, it gives its juice and then they will re-rank them. But re-rank them using search. So we can actually perform criteria and it will weight article based on how popular it is, and more importantly, for us, for adaptive learning, whether you like videos or you want articles, we'll give you more videos if you have clicked on more videos versus article. Now, this is kind of a contrived example. That's not really fully what a learning environment needs to be. But it's a good enough skeleton for us to prove out all the plumbing underneath it and get us there. And we're using Wikipedia articles, given that a big corpus of knowledge, a lot of metadata tagging, and full text to use that as an example. So if you zoom in a little bit and see that we are actually, based on the usage data we're collecting in Couchbase 2, we're able to use the Couchbase view to calculate the top contributor and top tags. So we've proven how that works. On the other hand, with all this content scoring about how popular an article is or what you prefer, video or text, we're able to now give you a slider, the popularity boost and user preference boost. I want an article that's more popular, but don't worry about my preferences. Just give me the most popular stuff. Or I don't want articles that's particularly popular, but I want something that fits my learning style. And then given those two sliders, I can still do whatever tags, search that I want to do. So this kind of collaboration between Couchbase and ElasticSearch allows you to do a lot of really interesting things. Because one of the things that is clear that some sort of the application needs will be, give me the content back in Couchbase the way I gave it to you. And that's where the left side of the screen is about. And we built this test harness, this learning portal proof of concept on Ruby. We didn't use the HTML5 stuff. Just to get started, we want to make sure that we have something that's well known, and then we're testing all the stuff on the bottom. And then you can also now do, what we're using for propagation is to use the same XDCR, cross data center replication mechanism, to essentially treat the ElasticSearch engine as almost another index mechanism. So instead of treating that as an enterprise search engine, you treat it as kind of part of your backend. And I'm going to use the same degree of rigor of replication to push all the changes into a new cluster. Now we get the benefit of the inverted index of a search engine, the performance that comes from being able to issue a query based on your intent and get something back. So this is roughly what we have done, and the glue code, it's written in Ruby, it's pretty easy to understand. But you can imagine building another layer of abstraction on top of that, or having your application, mobile application system on top of an API on top of that Ruby layer. And obviously, there's three types of content in it. They're in three different buckets. One is just the article and its statistics, not statistics, and its metadata, the tags and contributors and kind of things like that. The other one is a continuously updating what content you prefer as an end user, video or text. That's your user profile. And the statistics of the content is being collected in another bucket for efficiency and tunability. And once you have that, you can take a look a little bit about what the content metadata look like. It's a little bit small. This is just a little bit of the import from Wikipedia. You can see the categories that's already in the Wikipedia article. And the contributor is like who put this article in. And that hopefully would influence the weight of some sort. If we end up doing some comma stuff, that would give you a point or something. And then the user profile, when I click on an article, it uses an increment count within the Memcached protocol to be able to now do a running count. And you can certainly do a lot more counters to get more sophisticated analytics, but this thing is in there now. And it's very efficient because it leverages what Couchbase, the mem-based traditional Couchbase gives you. Now, this is the part that excites me. With this infrastructure in place, we can start looking at what problem we can solve in a more learning scenario. So the algorithm that is in the code that you can download today is what's on screen right now. So as the user performs the action, we log the user action. That user action changes two things. It changes the content preference of the user. Did you click on a video or text or an image? It also changes the content popularity of that piece of article. The bottom part, the content popularity, immediately updates the popularity, and then we can then push that new document into Elasticsearch so that it's waiting for you to query against that. Now, when the user requests, say, show me an article about volcanoes, right? I want to show a popular volcano video that is a video because that's what you prefer. That's when we traverse the second half of the step, leveraging the content that we have done, the recommendation or rating that we have done as the foundation, and use a very fast search query mechanism to do that. The alternative of not using Elasticsearch is that you have to pre-compute the recommendation for every user for every search they can do, and then do that in a Hadoop cluster, and you have all this explosion of, for John, I recommend these 7 things. For Stacy is this 16 other things. Here, we can kind of stop that step before it starts exploding on the Cartesian product between user and the intent and the content available and say, well, let's do that at the absolute last minute using Elasticsearch to do that kind of assembly. And that drastically reduce the amount of storage without necessarily getting in the way of other things. And that's the personalized content results that we can do. If you think a little bit more about the event logging, it's actually relatively simple, right? So as you do a click, I'm just saying, you access this resource at this time, and here's your name. And then that becomes the bottom layer, your fact table, if you want to look at it as a data warehouse, or your transaction log, if you're into that. And then that can be then aggregate using incremental map reduce into more useful constructs. And the key here is that these things have time to live, so they will go away, and it could be pushed into a cluster through some sort of mechanism that would not pick the wrong one. So it's like some magical Couchbase mechanism. And that's offline analysis for Hadoop will also be based on these things as a foundation. So that's the analytic and logging. If you flip on the other side, so what, when, who, when, the Elasticsearch, once you have this scoring kind of materialized in your search index, all you have to do is to essentially specify how you want to leverage this pre-existing aggregate that's in the JSON document in Elasticsearch, calculated in Couchbase. And you can say, oh, I want to actually boost my preference all the way up. And now when I issue this query, it's like, hey, show me 10 out of 10 versus 7 out of 10, and that will give you a completely different search results. And then on the other hand, for popularity, you can say, well, let me slide the popularity down as a way to get to more precise result for me, not necessarily just because a lot of people clicked on it. So this is what it combines together as a query. Those of you that may or may not know Elasticsearch, it's a DSL, a domain-specific language, allows you to express in a nested JSON construct a lot of strategies, like, okay, take this and boost it by that amount, and take that result set and sort it by this, and then take that result set and filter by these criteria. So it's a very expressive way of figuring out how to kind of filter this infinite large ocean of content. But what's really amazing about this is that we combine two techniques here, popularity and preferences. But if you look at Elasticsearch, you can do fuzzy searches. I want similar content to the one I'm looking at. Let's say I'm looking at a photosynthesis lessons. I can take the text of that and send it to Elasticsearch and say, give me content that's popular, that fits my learning style, that has these words in them, right? So you can use Elasticsearch, that's free. Like, you don't have to do anything. And that's really powerful content recommendation, kind of like EdSense, but with EdSense, using Elasticsearch the engine. Fuzzy matching, you can do facets to filter down what subset only things from the National Geographic. That's pretty obvious. Lucene expression allows you to build formulas that does ranking function. That's been pretty well proven as a really powerful way to do ranking without costing you a whole lot. Try express that in SQL and you basically not perform, right? But doing Elasticsearch is okay. I think the most important thing about that is that once you have this query DSL infrastructure, you can put more attribute and aggregate from Couchbase into Elasticsearch, and then you just have to figure out what I want to use for that. What is incredibly important to understand about search, given that we have this Google search preference, like kind of prejudice, a blank box of text, and you punch it in, is that a search is really a user intent. This is what I want to know right now. I want to book a flight. I want to look for something around this keyword. But an intent doesn't necessarily need to be explicit user action. So I could be viewing something and see recommendation. That's an intent. Give me something like this. I could have failed the test and give me something simpler, remedial material. That's another intent. And different intent will lead to different queries. But they could be embedded in your app in much more ways than just a search box. And that's, I think, what we're looking into the future about this kind of idea of EdSense, is that this is a generalized model about what we have done, is that we're taking an activity log, right, determining the learning style and the engagement, how many people have used it, have that inform the collection, add statistics to that, and then based on that, the user intent, what the user wants, provides a set of recommendation. So what we really want to do is to do it in as real time as possible. You perform the action, we immediately funnel this through and figure out what the correct reaction would be. And that's an adaptive system. Everything you do immediately affect what we ask you to do. This is the next thing you want to look at. Oh, before you go on, you might want to review that. These are things we can do in real time using this infrastructure. But what's missing in this diagram that we'll fill out in a short time is that we haven't talked about achievements yet, assessments, whether you learn something, whether you're successful in this game, or whether you have actually mastered this particular concept. Because once you have learning style, which is specific to a user, and achievement, which is specific to a user and maybe can be aggregate as well, and you have engagement about what people actually looked at, then you can achieve the holy grail in education, which is determining whether something worked at all. Efficacy, a big word, short, but big word, that basically said, was it worth the while? Is it something that actually worked? Did this drug actually cure your disease? Did this education content, did this game, did this animation, did this video actually help student of your type learn? I don't know if that yellow box is Couchbase or not, but I do know that the work that is on the left of that is the foundation for us to figure out whether we can implement that in Hadoop. Certainly, people have done that. Or if we want to do in what I said earlier in a more incremental way, could we inform that? Because then we can really achieve the EdSense vision that we have. So that's kind of what I have for how we have put together as a proof of concept. I'll add one more thing, which is that this really helped us with the UI. So from an Ember point of view, from a JavaScript MVC point of view, now we can go ahead and build these kind of very rich experience where every single tile, which is like a Pinterest tile of sorts or Flipboard, actually have all these metadata with them. You can edit them because they are read-write. They're not just a content delivery system. You can update your Couchbase if someone who has permission edits that. And that is accumulating all the attentions and energy that we know. And I think that's the foundation that we need, is that we need the instruments of learning to be telling the student and the system what's going on. Because if you walk in that classroom, you walk out and realize that nobody pays attention to you. How engaged can you really be? But if you have a system that looks at what you do, sometimes explicitly giving you a recommendation or reactions, hey, look at this, sometimes ambiently, it's like, I see you're struggling with this thing. And later on, at the right time, encourage you to learn something new or use a different way. I think that's the type of system that will really push this forward. And McGraw-Hill would like to be in the forefront of that. And our open source strategy begins today. So you can follow me on Twitter. We are pretty much in stealth mode until today. This is the first talk I've ever given on this topic. We will become much more open as we reveal some of the work that we've been doing. So mglabs.com, you want to sign up to get a beta trial on our Project Medici, which is our code name for our larger vision, of which the proof of concept is on the foundation of that. And finally, I'm here because I have open source software for you guys to look at. So the learning portal code that generated the UI that I show you with the document model is available for download. Play with it, extend it, contribute new aggregation to it, and then we can use that as the beginning of conversation of how we can use Couchbase and the NoSQL technology to really transform education in a deep and profound way. So thank you very much. Any question? Yes. Yeah, I think it's very important. The question is, how do we have preference actually be appropriate? It's very easy to have someone set up a preference on a website and actually it makes your website experience from that point onward worse. And what is the role of the teacher? I think the role of the teacher as increasingly is to help form and help guide student one at a time instead of just speaking in the middle of the podium and speaking to the 50%, to have more opportunity via online to suggest resources to specific student. The key, I think, with the analytics and the learning style is to not forget all the things that students are doing for themselves and teachers are doing for students, and try to generalize a little bit to help people make the better first decision. There's no doubt in my mind that the most insightful recommendation you will get will be from your instructor or from someone who's taking the same course. But it doesn't mean that we can't use the data, assuming the analytics improve over time, to make sure that the 6 things that you may want to pick on, the 2 things you want to look at first, are better than the other ones. Yes, I think the teacher dimension will become a lot clearer. So the idea is that the teacher's view of this is very much what we're working on. It is not in this more open source, kind of like mechanism, but we are seeing a tremendous large role. McGraw-Hill primarily goes to instructors to convince them to adopt our curriculum. We'll continue doing that in the digital age. In the coming months, as we become more public what you do, you'll see at least what we are thinking about the role of instructor versus student. How do they balance? What is classroom time? What is kind of outside of classroom time? So the question is that this presentation is mostly about delivering content that already exists, and what about acquiring content? And that's the part that I didn't talk about, which is the middleware layer that sits between the front-end HTML5 interfaces and the Couchbase and ElasticSearch. We are thinking about building essentially a broad API so that other organizations that want to push information into the cloud can register their content and how they want to get paid, if they want to get paid, into this system. But it's going to be indexed similarly, very similarly, as the Wikipedia article. So there are many ways to do that, but I think an open API is the best approach, where we stand as McGraw-Hill open to people using our delivery channel to bring their content to a larger audience. So any other questions? Otherwise, we will stop for lunch. So thank you very much, and I hope to meet you guys later in the